What's up, ladies and gentlemen? Mr. Deaver here. So, let's continue on today, starting with what we learned yesterday. Alright, yesterday we did some experiments. We had those balloons and we found that they could do some pretty cool things. If you watched, when you watched my video, you saw that I was able to levitate a little piece of plastic. It floated above the balloon, all on its own, or so it seemed. And I encouraged you to think, what could be causing that? Okay? Well, when you get right down to it, what caused it was static electricity. Okay, static means still. It's a kind of electricity that was just kind of still hovering on that balloon, a charge, an electric charge. And because of that electric charge, there was sort of this invisible force field that held the little piece of plastic up above it. And sometimes it did the opposite, and it would attract the piece of plastic and make it stick to the balloon. And then sometimes, at the end of class, we actually tried sticking the balloons to the ceiling, and some of them did that. So, where does that come from? Where do you get this invisible charge? Well, to understand it, we have to go down to the smallest level. We have to go down to the level of the atom itself. So today, we're going to start out by doing a little quick review. We're kind of going to bounce back to those ideas we learned about the atom, because without knowing that, you can't really explain what's going on. Alright, now I'm going to do some drawing, and while I'm drawing, I want you to make the same drawing. You can do it digitally if you wish, but I find it's easier to just draw by hand and then take a picture and insert it into my notes. So, how does the atom explain the force field thing? Okay, well, let's draw an atom. In case you've forgotten, the atom has a little central part, okay? A part in the very center of it that has a special name. It's called the nucleus. Okay, and in the nucleus, there are two different kinds of things you might find. One is called a proton, and the other is called a neutron. I'm going to color my neutrons blue, and I'll leave my protons red. So that's the middle, the nucleus of the atom. Then there's an outside part of the atom. We usually show it like a big circle. And there's lots of different names for this big circle. Some people call it the energy ring, some people call it the electron shell. There's different names for it, but the point is this. These rings are where the electrons can be found. I'm going to draw my electrons as two little circles on the outer ring. Okay, now a couple things that you need to know. First of all, let's make some labels. I want you to put a positive sign on these red circles, and I want you to label them protons. Okay? Protons are positive. See, this is the very beginning of understanding this electric charge thing, is understanding the charges of the different particles. They're called subatomic particles in the atom. Now, these little electrons on the outside, put a little negative symbol on those, because the electrons are negative. They carry a negative electric charge. Alright, so here's the key, one key thing for you to remember. Okay, so let's write it down if it's key. Protons and electrons have the special property of charge. They have a charge, an electric charge. And the charges are protons are positive, electrons are negative. And just so you know, these neutrons, that's the other, these other subatomic particles I didn't label. These are neutrons. These neutrons are neutral. They have no charge. They are not positive. They are not negative. So protons are positive. Electrons are negative. Neutrons have no charge. Okay, so why are we telling you this? Why is this important? What does this have to do with what happened yesterday, the mysterious forces? Well, check this out. If charges, let's write this down here, opposite charges attract. Okay, so for instance, if we have an object over here that is positive and an object over here that is negative, the two will be drawn to each other. Opposites will attract. Wait a minute, maybe this is starting to make sense. Yesterday when some of those objects mysteriously were attracted to each other, it must have had to do with opposite electric charges. Okay? On the other hand, like or similar charges repel. Repel means they push away. So if we've got a positive and another positive, they're going to push away from each other. If we have a negative and another negative, they're going to push away from each other. Opposite charges attract, similar charges repel. Okay, one last thing here. In this top corner, let's write down net charge. What in the world is net charge? Well, the net charge is the sum of all the charges. So let me show you how this works for this particular atom. Okay, so for this particular atom, which happens to be a helium atom, the two negative electrons and the two positive protons balance each other out. So you have two positive plus two negative gives a net charge of neutral. In other words, no charge to the whole atom. The whole atom is neutral. It would not be attracted or repulsed by another atom. What would happen if we, say, took away an electron? Now notice we have two positives and only one negative. So, two positives and one negative is going to leave us with a net charge of one positive. This atom becomes what's called a positive ion. It is net positive. Interesting. Well, what would happen if this atom happened to pick up an extra electron? What is it going to be now? Well, 1, 2, 3 negatives and 1, 2 positives. Now it has a net charge of an extra negative. Okay? So one more negative than positive makes this net negative. Now we have a negative ion. Okay, let's see how that happens. So this is how we come about to have atoms themselves that can have a positive or a negative charge. This is the basic, fundamental beginning point of the mystery that we saw in the balloons. Electric charges that are either positive or negative.